All right, this is going to be the video for notes 92. This is finding missing angles in right triangles. Now, we're still going to be using our trigonometry. So remember our little mnemonic device here. So, katoa. All right, and again, that is SOH. So that is sine is opposite over hypotenuse. CAH, which is cosine, is the adjacent over the hypotenuse. And TOA, so tangent is the opposite over the adjacent. Those ratios that we can set up, we can either solve, we've been solving for missing sides in triangles. Today we're going to do a solve for missing angles. All right, so first triangle here says to solve for the missing angles / sides in each right triangle. So what do we have? We have a right triangle. Love that. We have a y here, we have an x here. So here's the problem. We know neither of our two angles. So that's something we're going to have to figure out. We do know our two sides. So eventually we'll be able to figure out the third one. Actually, you know what? That's what I'm going to start with. I'm going to start with finding this side. So here's the thing. I'm going to completely ignore the x and the y here. That's irrelevant, at least for finding this side. So what I'm going to do is I know I have a right triangle here. And I know two of the three sides of the right triangle. So we're going to throw some Pythagorean theorem at this. All right. So Pythagorean theorem says a squared plus b squared is equal to c squared, or leg squared plus leg squared is equal to the hypotenuse squared. Now, which leg you use first does not matter in the slightest. So I'll go ahead and use 5 first plus z squared. So 5 squared plus z squared is equal to 12 squared. All right. Let's do some powers. Let's see. 5 squared is 25. Z squared is going to stay z squared. 12 squared is 144. All right, I need to subtract 25 from both sides. So z squared equals, what would that be? 119? This is where I'm going to grab the calculator because I think I did the math right. I'm going to clear that out. Let's see, 144 minus 25. I did do that right. Go me. Okay. So when we then take the square root of both sides, z is equal to, well, the square root of 119. So what could possibly divide into 119? So let me write that down first of all. So square root of 119. You can't have a negative, so don't worry about the minus plus sign. Let's see, 9, 10, 11. So 4 is not going to go in there. It's not an even number. 49? Yeah, it's not it. 119. 81's not going to work. 36 isn't going to work. It's not even. 25 is out. 16 is out. I don't think 9 works. No, that didn't work. I kind of just think we're stuck with 119 here. All right, we'll stick with 119. All right, so that tells me that this side is equal to 119. Square root of 119, I should say. Okay, so that's the thing. We've been doing Pythagorean theorem for a while, so okay, cool, we did Pythagorean theorem. Now I need to figure out either x or y first. It's not going to matter which one I figure out first. I just need to find one of them. So let's say I want to find x first. Okay, so this is what I'm going to mark as my reference angle. All right, star it, circle it, do something. And then that means that, let's see, the 5 would be the opposite side. The 12 is the hypotenuse. Okay, so x here, go across the triangle, that's your opposite side. Right angle here points to the hypotenuse, we're good there. So let me think, which trig function uses the opposite side and the hypotenuse? And that is going to be the sine. All right, so let me kind of shrink this down a little bit. So we are going to do the sine of x, because x is our angle measure, right? Sine of x is equal to the opposite over the hypotenuse. Now, in previous problems, when we set up ratios like this, your x was either the numerator or the denominator here. We'd cross multiply it. Great. Here's the thing. X is not part of that fraction. X is attached to sine. So we need to unattach this sign. Everything in math has an inverse operation. And the inverse to sine is literally inverse sine. All right, it's a little inverse sine here. So Inverse sine and sine do what they should do, as all inverses do, and that is they cancel each other out. So all that's left over here is x, and we need to do the inverse sine of 5 over 12. This is 100% a calculator thing, all right? So let me pop that calculator back up. There it goes. Now, you might be trying to figure out, how do I get inverse sine on a calculator? Well, I know where sine is, I know where cosine is, and where tangent is. I know it's really hard to see it, but right above these in little itty-bitty blue letters is inverse sine, inverse cosine, and inverse tangent. So to get the blue stuff, you're going to hit the blue button, which is second. So second, and then I'm going to hit the sine key. And I notice, oh, look, it's showing me that inverse notation. And I'm just going to write the normal fraction. So 5 over, right, 5 divided by 12. Close it up. Make sure you're in degree mode. So mode, yep, degree is highlighted. Okay, cool. All right, what this tells me is that x is equal to 24.6, rounded off to 2 decimal places, 62 degrees. All right, I'm going to lose the calculator. I'll come back to that in a minute. All right, so here's what I know. I know this side of my triangle is root 119. I know this angle of my triangle is 24.62 degrees. And the only thing left to figure out is y here. Now, there's a couple ways to do this. You could reset the triangle and do trigonometry based off of this side of 5 and this side of 12, but using y as my reference angle. The other option, or maybe you do a combination of both, is I know the 3 angles of a triangle are supposed to add up to 180. Well, I know that's 90. I figured out what x is, so I could use that to figure out what y is. Now, I'm going to go ahead and do the first thing, which is to use trigonometry, okay? I'm going to reset. I know I drew the picture in blue the first time. So the hypotenuse is going to stay the hypotenuse. Doesn't matter. Opposite, I'll just pull that, maybe. There it goes. Pull that out the inside. And I'm going to label now in, I don't know, orange, I guess. So if I talk about this, sorry about that, this angle up here, right, that's my reference angle. Then this side is going to be the adjacent side, and this side is still going to be the hypotenuse, okay? So that means as far as sine, cosine, tangent, which trig function uses adjacent and hypotenuse, that's going to be cosine. So cosine of y is equal to the adjacent side over the hypotenuse. And just like sine has the inverse sine, cosine has inverse cosine. And you use these when you're trying to find the angle measures. All right, when we're trying to get the y by itself here to get rid of that cosine, you need to use the inverse. So inverse cosine and cosine go away. You're left with y is equal to the inverse cosine of 5 over 12. And this is absolutely calculator work. Let me pop that back up. Good enough. All right. So again, you're going to do second and cosine to get the inverse cosine. Let me move that. So there's the inverse cosine. You see a little -1 there. And that's going to be 5 divided by 12. All right. So that gets me y is equal to 65.38 degrees. When I round it up, that works. Get rid of the calculator there. All right. So all this lovely work here. And let me highlight that answer. All right, so problem, I don't even think this is labeled, but you were asked to find the missing sides and missing angles. So we found the missing side first, did a little Pythagorean theorem here. Found the first missing angle using inverse sine. Found the second missing angle using inverse cosine. And here's the thing, it's all based off of what sides you know and can work with. All right, so that's the first question. And I'm pretty sure the second question is the exact same kind of problem. All right, so again, we have two sides of the triangle that we know, right? We have a side of 4 here, side of 16 of here, and we're going to find this hypotenuse. And then once we know that, we can figure out the 2 angles. And actually, technically, you can figure out the 2 angles first if you wanted to. All right, but let's see what we got here. In sides, I'm going to do a squared plus b squared is equal to c squared. Leg squared plus leg squared equals hypotenuse squared. This time I do know the 2 legs. So 4 squared plus 16 squared is equal to x squared. All right, 4 squared is 16. 16 squared is 256. I'll double check in a minute. And that's going to be 272, I believe. Let me pop that calculator back up here. All right, so I know what 4 squared is. I'm going to double check 16 squared. It is 256. I'm going to add 16, 272, and I'm definitely keeping this calculator because I'm going to take the square root of both sides. And I don't think 272 is a perfect square. Let me double check that. Yeah, no, that didn't work. But 272 is going to have a whole bunch of stuff that we can divide it up by. All right, so off to the side here, 272, I'm going to break this with a 2. It's 136. Break a 2 out of that. Going to be 2 and 68. Break a 2 out of that. So 2 and 34. Look at all these 2s popping up. And 2 and 17. Woo, that is a lot of 2s. All right, how many 2s do we have here? We had a pair of 2s here, a pair of 2s here, and a 17. All right, so the pair of 2s. And then another pair of 2s. So when we do our square root, you have 2 pairs of 2s. So that's going to be 2 times 2, which is 4 root 17 is your value for x. All right, so that's the one side using Pythagorean Theorem. Let me lose the calculator here. So using Pythagorean Theorem and simplifying your radical, this turns into 4 root 17. All right, that's what x is. All right, let's do a little bit of work here. Let me loop that up and move it. We're going to do a little bit of work to find a y and or z. You got to find both of them eventually. I'll go alphabetical order. No particular reason other than it's alphabetical. Let's find y first. So here is my reference angle. And so based off that reference angle, this side is adjacent, this side is opposite. The trig function that uses opposite and adjacent is TOA. That would be tangent. So tangent of y is equal to opposite over adjacent, so 16 over 4. And just like we talked about sine and cosine having inverses, so does tangent. There's absolutely an inverse tangent. So y is going to equal the inverse tangent of 16 over 4. You can reduce that if you want to. I'm just going to throw it in the calculator. The more I can make the calculator do my work for me, the happier I am. So I'm going to do the inverse tangent. So right above tangent in blue is inverse. So second tangent, there's the inverse. 16 over 4. And that is a very large angle. So 75.96 degrees, cannot be rounded. All right. Well, technically that is the round. It doesn't round up is what I should say. All right, so that's the first value for y there. And we got to do a little bit more work. We figured out x, we figured out y. Let's find z. All right, so z here, again, one of two things. You can use trigonometry to practice based off of this side of 4 and this side of 16. You can also, if you trust yourself that your y is correct, you can say, okay, well, I know this angle, I know this angle, and this angle are supposed to add up to 180. Well, this one's 90. That one we just figured out is 75.96. I could do a little bit of math to find z. I trust myself. I'm trying, not going to lead you guys wrong on these problems, but I'm going to go ahead and use trig for angle z here. And, whoops, there's we go. That's what I was trying to do. So let's do the reference angle here is z. I'm going to go in purple. So that's going to be 16 is the adjacent side this time. 4 is the opposite side from angle z. Right, opposite across the triangle, and the adjacent side and the hypotenuse make the angle that you're looking at. So again, what uses opposite adjacent? Well, it's still tangent. The difference is, of course, the ratio that we're going to set up. So the tangent of z is equal to the opposite over the adjacent. Okay, and so then I'm going to, of course, just like last problem, I'm going to use the inverse tangent. So inverse tangent, inverse tangent. So tangent and inverse tangent cancel. So z is equal to the inverse tangent of 4 over 16. Again, reduce if you want to. I'm just going to throw it in the calculator. There it goes, as I can make the calculator pop up on screen here. So inverse tangent of 4 over 16. Here's my parentheses. All right, that should be z is equal to 14.04 when rounded, and it's in degrees. So lose the calculator. If you want to double check to make sure that things are looking right, you can take your 90-degree angle, the right angle that you started with, the value you figured out for y and the value you figured out for z, and make sure they add up to 180. Or maybe you could be off by a decimal point here or there, simply because sometimes you might round differently, but you should be at least really close to 180, maybe a touch over, a touch under. But if you're getting something like, 175, something's probably wrong. All right, so that's going to be the end of this video for notes 92, I believe. We found all the bits, parts, and pieces for both of our triangles using still SOHCAHTOA, or sine, cosine, and tangent. As always, let me know if you have any questions or concerns, and I'll see you in the next one.